this area right here. So Eric, that is correct. Because any answers after this is going to be, won't have any points since somebody already got it. So Diva and Eric. How about this one? This one's a little bit harder. So whoever gets it first will get the... So Amy says primary amine. So we have two things going on here. What are the two things? Whoever gets it first will get the full point. If two people say it at the same time, like one after another, then yes. So Eric says NH2, so we have a primary amine, and then we have CH3 and CH2, which is correct. So here we have the CH3 and then the CH2 lingering, and then we have a primary amine. For one more point, for this primary amine right here, can somebody tell me the reason why it's so, why does it look funny compared to this very nice sharp peak? Why is it so broad and not very sharp? Yeah, so dilute, hydrogen bonding. Actually, no, if it's more concentrated. So if it's dilute, it's going to be more, it's going to have more sharpness to it. So hydrogen bonding, whoever said hydrogen bonding, concentration is good. That's a good answer, possibly contaminated with water, because that also gives you hydrogen bonding. Actually, I'll accept that too. That's a pretty good answer. Alrighty. There's some extra ones that you guys can look at for practice. So here you can see this is not be a this should be a secondary, not a primary amine here. Alcohol, CH3. This looks like an aromatic, I think. I have the chat blocking my view, so I can't see. So yeah, there's extra problems here to look at for practice. This is very, very broad OH group here. This is a very concentrated carboxylic acid from the look of it. You have the carbonyl here. And then, before I finish, this is just a nice table to look at. And I'm sure your book also has tables for you guys to look at as well. So you have the bond types, the approximate wave numbers of where they should be located, and how the peaks should look based on intensity. So from strong to medium to short. Yeah, they're posted. They've been posted since the first week. They're on the beach board. So everybody can use this. This is for you guys to use. Now let's just quickly go over the lab worksheet. Okay. This is going to be due 2 weeks from now, so not next Friday, but the following Friday. And then we meet next week to talk about simple and fractional distillation. And there's a quiz next week too, so don't forget that. So use the PowerPoint slides, which I went over, and then use your textbook to answer these questions, to help answer the questions. So first question, how could the pair of structures shown be distinguished using IR? List the diagnostic peaks in wave numbers that would be present or absent for each pair. So on the side here or wherever, what you can do is look at each structure, look at what functional group is characteristic, right? That would be very characteristic on the spectrum, using notes, right? And then you're gonna wanna label those wave numbers corresponding to those functional groups. So you have some sort of a mean here, right? So write the wave number and do that for everything else for the other 4 structures, and then explain where you would find those on the IR and what should be present absent from each pair. So this has this, which is not present in this, vice versa. This has this, that's not present in these, and vice versa. And then this one has this, but doesn't have what these have. So you can write it that way. So this is more of a question that's for you to critically think, not just to label, okay, this is this on the IR, this has this peak on the IR bar, but why this is different in the IR from this one, like what this has that this one doesn't have, and you can do that for all of the structures as well. And then for the number 2, you're going to be given, this is an IR that you're given, and then you have to choose one of these 3 structures to label your IR. So which structure is all of these peaks representing, or at least the characteristic peaks. So then you circle your answer and then label, you can write your structure here and then circle it and then label each peak. And then that I can see. So you want to label whichever structure you choose, label the peaks on the structure that are characteristic on an IR, and then on the IR, label those peaks as well. So I can see which portions of the structure you're talking about for each peak. And the last one, you have 7 IRs. So 1, 2, 3, 4, 5, 6, 7. You have a box next to each IR, and you're supposed to choose a structure from the structure bank here. So there's 10 structures, so you won't be using all structures. And then again, similar to the previous problem, label why. So you have your structure drawn here, and then label the wave numbers, and then label the peaks with those wave numbers and the portion of the structures that represent the type of bonds that are occurring in the structure. So label everything from the structure that you draw to the IR, everything in the IR, so they can see that this is where you're getting this from. You know, this peak represents this from that structure. And you do that for all of them. So you just look at each structure individually, know what type of peaks you should expect, compare them, and then make your decision based on the IR. So look at the IR. Do those things match? You might have one or two structures or three that might have something similar to one specific IR, or you have multiple IRs that are very similar in terms of peaks and that represent a portion of the structure or the functional group. So yeah, that's pretty much it for the worksheet. Any questions?